Hey y'all, welcome to part 2 of your Unit 1 test review video. This is number 16 through the end. If we look at number 16, it asks us to solve by the square root method. Since there's only one x in the equation and it is squared, we can just isolate that x instead of expanding it and then doing some other things. So isolate that x, we'll add the 3. So x minus 4 all squared will equal 9. Then we need to get rid of that square. So we'll take the square root of both sides. Square and square root undo. So that's x minus 4 equal to, the square root of 9 is 3. And since we took the square root, it is a plus or minus 3. Now, we need to add 4 on the other side. So we have two solutions here. We have x equaling positive 3 plus 4 and x equaling the negative 3 plus 4. So our two solutions here are x equals 7 and x equals 1. You do need both solutions. Now, let's talk about completing the square. To complete the square, we start with just x squared plus bx plus a blank. We use the b coefficient, and then we do our process. Half it, box it, square it, and then we add it and undo it or balance it. So we need to start with x squared plus 8x plus a blank, which means we need to add the 3 on the other side, and we need to add the blank on the other side as well. Then start with the b, it's going to be the 8. Take 8 divided by 2, we get 4. Put a box around that number. We're going to use it in a minute. Square it. 4 squared is 16. It's the 16 that we add on both sides. Now, x squared plus 8x plus 16 is a perfect square. It's the perfect square of x plus 4. This number that we drew the box around is what we used later. And then that is equal to 3 plus 16 is 19. We have completed the square. Now, we want to solve this problem. Everything on the left side is in a square, so we square root both sides. So the square and square root undo each other, give us x plus 4 equal to plus or minus the square root of 19. Plus or minus because we had to take the square root in order to solve. Then we need to subtract the 4. So x equals negative 4 plus or minus the square root of 19. And you can leave it like this. You don't have to write both out when the square root won't simplify. So let's talk about some transformations. If we look at 18, it's a quadratic equation. Everything except the x and the square causes a transformation. So if we look at the transformations, think order of operations. Inside parentheses first, that's a minus 1. Inside the function, it's left, right, but it feels backwards. So that will be right 1. Then we, after parentheses, we would multiply. So we multiply by that 1/3. That is a vertical shrink or compress by a factor of 1/3. And then the next thing we would do would be add or subtract any terms. So that's the minus 7. That's vertical, up and down. it moves down 7. Vertex, to find the vertex, consider vertex form. That's y equals a times x minus h all squared plus k, where the vertex is h comma k. The vertex here would be 1 comma negative 7. We moved right 1, we moved down 7, so that vertex is at 1, negative 7. The axis of symmetry is a vertical line, so its equation is x equals a number. That number, to be more specific here, has to be the x coordinate of the vertex for that axis to go through the vertex. So our axis of symmetry here is x equals 1. Here's our transformations, our vertex, our axis of symmetry. Let's do the same thing on number 19. Inside the parentheses first, that minus 6 moves left 6. Yes, that feels backwards direction. Then we multiply. That negative reflects over the x-axis. The 5 is a vertical stretch by 5. And then we would add or subtract. That's a positive 10, so we go up 10. Our vertex would be 6. I wrote that down wrong. That's a minus 6, which feels backwards, so that's right 6. Sorry about that, y'all. And our vertex is 6 comma 10. The axis of symmetry is that vertical line, so it's x equals 6 to go through the vertex. Transformations, vertex, axis. Now, let's take a look at functions of functions. Let's look at number 20. We have f of x and g of x. We're doing f of g of x. Since there's nothing to work out for g of x, there's not a number to plug in, we go straight to the f function. F function says square root of 3 times stuff plus 1. The stuff we're putting in is g of x, x minus 7. So simplifying this, square root of 3x minus 21 plus 1, which is equal to the square root of 3x plus 20. F of g of x. Let's look at 21. We're doing the other direction, g of f of x. There's nothing to work out for f of x, so we'll go to the g function. G of something says take the something and subtract 7. The something we're plugging in is the f function, which is square root 3x plus 1. We can't combine a root with a non-root, so this is simply square root of 3x plus 1, then outside of the root minus 7. And there is g of f of x. If we're looking at 22 and 23, we're doing, we have values, f of g of 10. So we're doing g of 10 first. G of something says something minus 7. That something we're plugging in is the 10. So g of 10 is 10 minus 7, which is 3. And now we need to do the f function. That is not what I wanted to write with. We do the f function. F function says square root 3 times stuff plus 1. The stuff we're plugging in is what g of 10 equaled. So it's the 3 we got in the first step. Simplify, this 3 went right here. Simplifying this, 3 times 3 is 9 plus 1. This is square root of 10. And let's look at 23, g of f of 8. We'll start with the inner function f, which says square root of 3 times something plus 1. That something we're plugging in is this 8. So then that is the square root. That is the square root of 25, which does equal 5. If that's a perfect square, you need to simplify it. It's not a plus or minus because the square root sign was already there. We did not take the square root to solve. So now we do the g part of this function. G of something is that something minus 7. The something we're plugging in is the result we got for f of 8. So that's g of 5 is 5 minus 7, and that is negative 2. There's your final answer. There's functions within functions. So let's take a look at this last page and let's look at our graph. We are using this graph to find vertical asymptotes. Remember, asymptotes are lines that a graph approaches but does not touch. So we have this vertical asymptote, this dashed line here, that is at x equaling negative 1. It's the equation of a line, so write it as x equals. We have another vertical dashed line here at x equals 6. So those are the 2 vertical asymptotes. Then the horizontal asymptote is this horizontal line that the graph levels off at. And that is a horizontal, so it's y equals, and that is at y equals 3. So there is your vertical horizontal asymptotes. Okay. Domain and range, start on the left. This arrow goes to negative infinity, and it goes up to that vertical asymptote, but doesn't touch it. So then it starts over again at the vertical asymptote, and it goes to the next vertical asymptote at 6. Then it starts over again on the other side of 6, and it goes to infinity. On the range, label that. On the range, bottom to top, okay? If we look at this, we do have a horizontal asymptote, but that middle section crosses that horizontal asymptote. So there is actually no break there. Your range is all real numbers. Now, let's talk about limits, okay? Good thing to do is at each vertical asymptote, dashed line, label left side, right side, top and bottom. Left side, right side, top and bottom. So, first one wants the limit as x approaches negative 1. Here's x equaling negative 1. That minus means on the left. So, if we look at the left of that asymptote, there's nothing on top, there is something on the bottom. So that limit is going down, 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 down to negative infinity. Okay. On that same vertical asymptote, but on the positive side, on the right, if we look at the right side, the graph does exist there. On the right side of this asymptote, there is no graph. So that right side is going up, 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 up to positive infinity. We'll do the same idea at the other asymptote at x equaling 6. Label bottom, left, right. Label top, left, right. First thing it asks us for is on the left. If we look at the left up top, there's no graph. If we look at the left on bottom, there is graph. So that goes to negative infinity on that left side. Same idea on the right. On the right side of that asymptote up top, there is graph. There is no graph on the right side of it on the bottom. So that goes to positive infinity. Okay. At vertical asymptotes, the limit will always be either plus or minus infinity. At a vertical asymptote, those limits will always be plus or minus infinity. Now, let's look at as x approaches negative infinity and positive infinity. Remember, this is the far left edge of the graph. As we go further and further left, we are approaching that horizontal asymptote of 3. Same thing on the right. As we go farther and farther to the right, we are getting closer and closer to this horizontal asymptote of 3. So for the far left and far right, use the horizontal asymptote. Okay. All right, and one more quick thing. These formulas here are all given to you on the test. Those formulas are all given to you on the test. All right.